everyone, welcome back to Science Lessons, and today's free, fun, practical science lesson is all on magnets. So I'm just going to move this around so you can see what we're going to do with the practical activities today. We're going to talk very briefly about what magnets are first and where they were discovered. In fact, years ago, magnets were first discovered in rocks, and some of the rocks had iron in them. And when people held up the rocks with iron in them attached to a bit of thread, they would always point north. So they were known and could be used as a compass because they would point the direction north for people. And then what happened is when they came up with magnets that you know today that look like this, the end that always pointed north, they then named the north-seeking pole. And the end that then pointed south, they named a south-seeking pole because it was in the opposite direction to north. And they have since been abbreviated to the north pole of the magnet and the south pole of the magnet. So that's a fun and interesting science fact for you about how magnets got their name. Okay, so let's move on to the practical activities today. Key stage 1 are going to have a look at doing a fishing experiment. Key stage 2 are going to look at like and unlike charges. Key stage 3 are going to look at magnetic fields. And key stage 2 will also do key stage 1, key stage 3 will also do 1, 2 and 3, and key stage 4 are going to look at electromagnets. But actually in your curriculum key stage 4, all of these things are covered under what is magnetic, like and unlike charges, and the magnetic fields. They still appear in your curriculum, so it'll be useful for you to do all of them. So let's start off today then by looking at what Key Stage 1 children can do, and they could have a nice activity with their parents that I've named the magnetic fishing activity. So what I've got here is I've got some paper clips on my saucer, just like that. And paper clips are magnetic, so if we put our magnet onto our paper clips, you'll see that they are magnetic. And you might not have one of these magnets at home, and as you know, I'm always trying to do experiments that you can do at home, even if you don't have the science practical kit, because you're not in a lab. So you probably all have some of these at home on your fridge, some fridge magnets. I've got one here that says I love shoes, and I do love shoes, and people that know me know that I love shoes. But you've probably got loads of these magnets on the fridge. I've got one here. I've got another one that says a girl can never have too many shoes, and that's also another magnet that goes on your fridge. You could use these in your activity if you don't have a normal magnet. You can see what I've done here is I've just attached a piece of string to this fridge magnet that I have, and you could have done the same to this one. And what you can do is you can cut out lots of little different shapes of different types of fish. And then when you've done that with your piece of paper, which I'm going to do here right now, I've just ripped off a little bit of paper. I'm going to cut out a shape of a fish. So I'm going to start off by just doing that little bit like that, and then there's my fish tail, and I'll show you what my shape of my fish looks like in a minute. It's probably not going to be very good, but you never know, it might be okay. Just using a scrap bit of paper so I don't waste anything, so we can protect the planet and all that. And here's my little fish. So I've just done a little shape of a little tiny fish like that, and what I'm going to do is I'm going to attach the paper clip to my fish like so that it now becomes a magnetic fish. And you can do lots of different shapes, lots of different colours. You can have lots of different aquatic fish, and you could place them all onto a tray or a container, and then you can get your magnet on your string and try and catch your fish with your magnet. That's a really fun activity for them to do. It does usually tend to make them laugh quite a lot as well. So I recommend that you do that with them and take some pictures of them doing the activity. I would like to see what wacky and weird and wonderful shapes and colours of fish you have made and how many you can catch. Can you catch more than one in one go? And that would be pretty amazing too. So Key Stage 1, have a look at doing that practical activity and downloading the attached worksheet that's suitable for Key Stage 1. That's now your opportunity to have a go at doing the activity. But before you go, I just want to show you something. On my shop, where I sell my pound practicals, this is number 11, which is called Magnetic Mayhem. Remember, these are only £1, so you could log on to the shop, the link is in the description, and perhaps you could have a go at getting one of these as well, because they're great fun. There's loads of practical activities in there, and there's a magnet enclosed and everything, so you can do that activity too. And there's even answers about how it works on the back of the card, on the method card in there, so have a go at that. Thank you. Right, Key Stage 2, you can have a go at that activity too, but we're also going to look at like and unlike charges. So, you again might not have magnets that look like this and that are labelled with the North and South Pole like my magnets are, but again you will probably have a couple of magnets on your fridge like this that we showed you earlier. So I'm just going to take off the little bit of string. We're going to look at like and unlike charges because we talked about how the magnet is known as a North and South Pole. And in fact, if we place two North poles together, they repel each other. You can't push them together. They force each other apart. And the same is true of the two South poles. If you try and force them together as well, they don't allow you to touch them. So, like charges repel. And that means that they won't attract to each other, they repel and they push each other away. And that will appear on your worksheet. However, if we get unlike charges, a North Pole and a South Pole, and we push them together, they attract and they touch each other. So we can do that with them as well to show that that's the case. And that means that two unlike forces attract each other, and that will also appear on your worksheet. If you don't have magnets like this, you can have a go at trying with your magnets on your fridge and seeing what happens if you put two of them together. Do they attract each other like these two do, or do they repel each other? And if they repel each other, you will know that they are like charges because you've just learned that, so well done. Okay, so I'm going to put those down. So that's the activity for Key Stage 2. Don't forget to also have a go at the Key Stage 1 activity on the fishing experiment. Take pictures, tag me on all the usual things on Facebook or Twitter, or email them to me on esgate-green@superscientists.co.uk. Thank you. Okay, Key Stage 3, we're going to have a look at magnetic fields now. So I'm just going to briefly draw a diagram on the board here, underneath where it says Key Stage 3. I can't draw left-handed, so I'm going to come round the board and draw on the other side, so bear with me a second. I'm turning around. Here I am again. So what I'm going to do is I'm going to draw my magnet here, and we've got a North Pole and we've got a South Pole. Now there are invisible, we can't see them with the naked eye, magnetic fields surrounding our magnet. And if you've done this experiment at school, you might have heard of an experiment that you did with a magnet and some iron filings. And when you put iron filings over the top of a piece of paper with a magnet underneath, iron filings, and as we know, iron is magnetic, so it will naturally be attracted to the magnet, but it will form these magnetic fields. And the magnetic field on a magnet always moves from north to south. So this is also relevant for Key Stage 4, because if you were going to get an exam question on this, you would have to show the direction of the force, or the current, if you like, or the magnetic field. So you would have to draw arrows on there. So it's useful to remember that it moves from north to south. So we're going to draw that now, where we show that the magnetic field is moving like this. Just press a bit harder. From north to south, like this. From north to south, from north to south. It's going over my writing, but that doesn't matter. And we would show a direction of arrows going like that, from north to south, yeah. And then the magnetic force on the other side does the same thing, but it's coming from north to south, from north to south. So you have to remember that all the time, okay? So from north to south, from north to south. Okay, so that's the magnetic field. That will appear on your worksheet, but I've got another activity that you might like to try. So I'm just going to move this out of the way. So if you've got a pair of scissors and you have a magnet from your fridge, like we said earlier, you can magnetise your scissors. And all you do is you move your magnet down in the same direction along your scissors. And when you've done that, you should be able to show that the scissors become magnetic. I'm going to move it a little bit closer so that you can see. And I'm going to use my bar magnet. Let's take this little fish off of here. Okay, so I'm going to move my magnet down my scissors like that in one direction. And then I should have magnetised my scissors, and they should be able, it's not very strong, there we go, to pick up the paper clip. Oh, it's just not very strong. There we go. You see it does work. And I should try it again. There we go, in one direction. And it's closed. Let's have a go at doing these. Oh. This is what happens when you try to hold something at the same time, isn't it? Let's have a go. What I've actually done is I've got a neodymium magnet out here from my metallic putty, because those magnets weren't particularly strong. So I'm going to show you with the neodymium magnet. You can see how strong that is because it's just automatically been attracted to the scissors. I'm just going to move it along in one direction like that to magnetise my scissors, and then I should be able to see how strong it is now. That's worked a lot better, hasn't it? Be able to magnetise my scissors, which I have done, to enable me to pick up some paper clips with them. So you could try that with a pair of scissors, but your magnets standard magnets that you get off the fridge are not very strong, so it might not be as good as that magnet that I just used then, but you might be able to pick up one magnet just a little bit off the worktop, which is still pretty cool. The other thing I was going to show you is that you might have heard of magnetic putty. You can make this yourself with some PVA glue and iron filings, but basically magnetic putty has got little particles in it of metal that are magnetic, and you can place it over or near some magnetic putty and put the magnet near it and it will be attracted to it, which is pretty cool. There's lots of different makes that you can get, and I've got a blue one here as well, look. I think this one's from the Science Museum. You've just got to get it out of the tin, be brave and get your fingers in there, and try not to leave it on the couch or something if you've got material couch, because that's not going to be good. You can see the magnet here. If I move these off the tray's a bit dipped, so I bet you if I turn it round it'll be better because it's a surface that you can see a bit better. Oh, did you see that? I'll do that again. I'll put the magnet over there and I will bring the putty close to the magnet and you can see what happens when it gets a bit closer. Oh, do you see that? If we watch it carefully, ooh, try and keep it straight. There we go. if we watch it carefully, we can see, and I can feel it, can you see the magnet being pulled into the magnetic putty? Yeah. It's better if we put it like that on top, and then you can see and hold that. In fact, if I take that away and just hold it like that, that's probably just as good for you to see. And you can see the magnet being absorbed into the magnetic putty. That's pretty cool. You can buy those magnetic putties off of Amazon. They're not very expensive, and other places too. Good, I'm going to place that back inside there. Okay, another activity that you could do that's really good is you could just get a bag of loads of different items, or just collect loads of different items from your household and put them on the tray. Oh, I dropped one here, pick it up. You can get, I've got a marble, I've got a lid from a glue stick. Put the marble in there so it doesn't keep running around. I've got a bit of wood from the garden, 5p piece, safety pin, a dart, push pin, a rubber, and a sharpener, pencil sharpener. So what you can do is you can use your magnet to see which of these are magnetic and which aren't magnetic. So yeah, the 5p pieces. Yeah, the safety pin is. Yeah, pencil sharpener is. Glue lid, not. Marble, not, and so on. So you could do that experiment. Then you could draw down or write down your results on a piece of paper, and you might notice something about all the properties, or the properties of the materials that are magnetic compared to the properties of the materials that aren't magnetic. So you could come up with a table, one side that says magnetic, the other side that says not magnetic, and just use your fridge magnet and see what you notice about what things are magnetic and what things aren't. It's just another cool science experiment that you can do at home without having loads of equipment. So Key Stage 3, that's your activities that you can do, and don't forget to have a go at the Key Stage 2 and the Key Stage 1 activity too, because it's scaffolded. And finally, Key Stage 4, we're going to have a look at electromagnets. Okay, so Key Stage 4, let's have a look at electromagnets then. I'll just put this down. So, let's have a look at an exam question. This is my drawing of a simple electromagnet. Question 1 says, describe how an insulated wire and an iron bar can be used to create a strong magnetic field when a current is passed through the wire. So we can use this diagram to help answer this question actually, because electromagnet, or an electromagnet, is actually just a solenoid which the insulated wire is wrapped around an iron core, and in this case the iron core is a nail. When the current passes along the wire, the insulated wire here, so we've got to the battery and to the battery, when the current is passed along that insulated wire, a magnetic field is created. Yeah. And that magnetic field in turn magnetises the nail. So it can act as quite a strong magnet. So it magnetises the iron bar, or in this case the nail. When the current is switched off, the magnetic bar or the nail, as in this diagram here, loses most of its charge. So that is how an insulated wire and an iron bar can be used to create a strong magnetic field. Question 2 says, why would an electromagnet be used in a scrapyard as opposed to just a magnet? If you think about a scrapyard, that is where cars are picked up by a magnet and moved from one place to another place. If you just used a normal magnet and you picked up the car, how would you then get the car off of the magnet to move it somewhere else? So really it's looking for the answer for this question to show you the difference between a magnet and an electromagnet. And an electromagnet in this instance for a scrapyard can be switched off and on, and you can't do that with a normal magnet. So you would switch it on to magnetise it to pick up the car, and then you would move it to where it needs to be and then switch the electromagnet off, and the core would lose its magnetism and it would turn off the electromagnet and the car would drop. So that's how an electromagnet is better than just a normal magnet. So that answers those two questions. Okay, thank you everybody. That is the end of the free practical science lesson for today, and hopefully I will see you again tomorrow. Thanks then. Bye.